Hello everyone, I am Ms. Megha Karwal, Department of Civil Engineering from Praveen Patel College of Diploma Engineering and Technology, Bhinder. I warmly welcome to all of you in today's lecture. In today's lecture, I explain you second chapter, track geometry construction and maintenance. Now we start the first topic of track geometry construction and maintenance. Alignment. Alignment of railway line is refers to the direction and position given to the center line of the railway track on the ground in the horizontal and vertical planes. Marking the position of center line on ground and giving direction to the railway track is known as the alignment of railway track. So, what is a horizontal alignment? Horizontal alignment means the direction of the railway track in the plan including the straight path and the curve it follows. Vertical alignment means the direction it follows in a vertical plane including the level track, gradient and vertical curves. Factors governing the rail alignments are as follows. So, first factor is obligatory points. Obligatory points, many times alignment of track has to be divided from straight line because it has to passes through the obligatory points. So obligatory points like marketplaces, industrial places, education centers, etc. So certain undesirable location have to be avoided. Example, low-lying area, marshy places, areas requiring deep cutting. So they may need deviation of the alignment. Second is traffic. The alignment should suit the traffic growth and its impact should be studied carefully and the alignment should pass the thickly populated areas. Next is geometric design. To get the maximum benefits out of a railway alignment, the geometric design of the following elements should be made very carefully. First is gradient. Gradient should be considered. Gradient means difference in the elevations. Second is radius of curve is lesser. Next is the use of curve should be particularly avoided. Large bridge should be crossed by alignments at right angles. The effect of rise and fall of ground should be considered and the effect of distance on operation express should be considered. Next is topography area. If the topography area such that the use heavy gradient is unavoidable, then in such a case the alignment of track is made by special ways to reduce the rate and cost of high gradient. Next is economical consideration. The alignment should be economical, so the initial cost and cost of maintenance and also vehicle operation cost should be taken into consideration. Last is other consideration. From drainage point of view, marshy tracks should be avoided. The alignment should be such that the excessive cutting of the rock is avoided. The waterlogged area should be avoided and cuttings in a snowfall area should be avoided as it will create the problems of cleaning the track in a cold season. Okay, these are the other considerations. Now next is gradient. Gradient, the rate of rise or fall provided to the formation of railway track along its alignment is known as a gradient or grade. Factors affecting the gradient. So various factors is affecting the selection of gradient. First is nature of ground. Next is the total height of the cover to be covered, drainage required, safety required. These are the factors is affecting the selection of gradient. Next is types of gradient. Ruling gradient. The gradient usually adopted while making the track alignment is called as a ruling gradient. Pusher gradient. These are steeper gradient than the ruling gradient and are provided at a certain places of mountains to avoid a heavy cutting or to reduce the length of the track. Momentum gradient. Gradient which is steeper than the ruling gradient and where the advantages of momentum is utilized is known as a momentum gradient. Station yard gradient. Station yard gradient is the minimum gradient provided in a station yard for easy draining and rainwater. Curves. What is a curves? Curves is as far as possible. Railway track should be straight, but due to the various unavoidable reasons, curvature is to be provided. So that's why we provide the curve in our roads or railway tracks. So curves are provided to connect the important points and avoid the obstruction. Okay. So factors affecting the curve. First is to attain the gradual rise, to give the comfort to the passenger, to give smooth running, and to join the different gradient. These are the factors affecting. Types of curve. Horizontal curves. Horizontal curves are necessary when the change in the direction of travel is to introduce. These curves are in the horizontal plane. Next is vertical curves. On the track, the vertical curves are provided in the vertical plane where the gradient change. So there are the two types of vertical curve, summit curve and valley curve. Summit curve. The curves provide where the intersection of two gradient has the highest elevation. The situation where the summit curve is provided in first case is a rising gradient intersect a falling gradient. Second case is a rising gradient meeting another rising gradient. Third case is a rising gradient meeting horizontal path, and fourth case is a falling gradient meeting at a steeper falling gradient. Valley curves. Valley curve has a convexity downward direction. So the point of intersection of two successive gradient has the lowest elevation where the valley curves are introduced. So here four cases. First case is a falling gradient intersecting a rising gradient, a falling gradient meeting another falling gradient. Third case is falling gradients meeting a horizontal path. Fourth case is a rising gradient meeting a steeper rising gradient. Okay. Transition curve. It is seen earlier that the road on straight alignment has a camber while on the curve. It has to provide with the super elevation. Obviously, the change from camber to the super elevation cannot be sudden. It is therefore desirable to introduce the curve on either side of the horizontal curve, which permits gradual change in the super elevation. The curve should have a varying radius changing from its junction with the straight alignment of the track to finite radius of the circular curve. Such a curve is known as a transition curve. Okay. So next is a grade compensation on curve. Grade compensation on curve. So on curve portion on a railway track, extra power is required to pull the train due to more attractive resistance. Therefore, to overcome this, increase tractive resistance to certain limits and pull the train with the same speed. Gradient on the curve are reduced. So here you can see in this image. So this reduction in the gradient on curve portion of railway track is known as a grade compensation. Okay, it is expressed by percentage per degree of curve. On the Indian Railways, following values of grade compensation are recommended. For broad gauge railway track is 0.04%. For MG road railway track is 0.03%. For narrow gauge railway track 0.02%. Super elevation. The inner rail of track is kept low as compared to the outer rail at different curve. This rising of outer rail is known as a super elevation. To counteract the effect of centrifugal force, the level of the outer rail is raised above the inner rail by the certain amount to reduce the centrifugal force. The term cant is frequently used for super elevation, but cant should be used to represent the angle of transverse slope. So the main functions of super elevations are the following: to have a better distribution of load on the two rails, to reduce the wear and tear of rails, to neutralize the effect on the lateral force. Limit of super elevation. The maximum values of super elevation according to IRP is usually taken as 1 divided by 10th of gauge of the track. So maximum SE for super elevation for broad gauge is 1/10 into 1.676 into 100. Maximum super elevation for meter gauge is equal to 1/10 into 1 into 100. Maximum super elevation for narrow gauge is equal to 1/10 into 0.6762 into 100. These are the images of super elevation. Next topic is cant efficiency. The difference between the equilibrium cant necessary for maximum permissible speed on the curved track and the actual cant is provided is known as a cant efficiency. Cant efficiency involves traveling through a curve faster than the balance speed and produce the net balance speed and produce a net lateral force to the outside of lateral force to the outside the curve. It should be as low as possible. Cant efficiency defined as when the theoretical cant required is greater than the actual cant is provided at the speed of the train. The difference between the theoretical cant and the actual cant is called as cant efficiency. Okay, so it is limited due to the following disadvantages of providing less super elevation. First is higher cant efficiency result in extra pressure and lateral thrust on the outer rails, which is required strong track and more fastening for stability. Next is higher cant efficiency result in more side wear and creep of outer rail of track. Third is higher cant efficiency is result more discomfort to the passenger. So this is an image of cant efficiency. Next is negative cant. On the curve where the main track and branch tracks is meet, then the stage occurs such that the outer rail is below the inner rail, then it is called as a negative cant or negative super elevation. So definition, this is a definition. When the main lines lies on the curve and has a turnout of country flexure leading to a branch line, the super elevation necessary for the average speed of trains running over the main line curve cannot be provided. In the figure below, AB, which is the outer rail of the main line curve, must be higher than CD. Okay, point A should be higher than point C for the main lines. However, CF should be higher than AE, or point C should be higher than point A for a branch track. These two coordinatory conditions cannot be met within the one layout. In such cases, the super elevation provided on branch lines curve, and such a super elevation is called as a negative super elevation, and therefore speed on both tracks must be restricted, particularly on the branch line. Coning of wheel. The tread of the wheels of railway vehicles is not made flat but slope like a cone. An outward slope of 1 in 20 provided on tread of the wheel to prevent lateral movement of the axle and to prevent from rubbing the inside face of the rail head. The outer slope of 1 in 20 on the wheel tread of railway track is called as coning of wheel. Again, the coning of wheel means the wheels are coned at a slope of 1 in 20 to prevent from rubbling the inside face of the head and to prevent the lateral movement of ankle with it. This is known as a coning of wheel. Thank you.